Um, Good afternoon, everyone. My name is Alyssa Bobalik. Accompanying me today are my teammates, Olivia Hope, Jacob Pannell, and our project manager, Michael Rechtin. Over the past year, we have studied the course scheduling process at the University of Arkansas with the support of Gary Gunderman, the Executive Director of the Office of Institutional Research and Assessment, and Colleen Briney, the Vice Provost for Planning. Through our studies, we have identified opportunities for improvement within the course and classroom scheduling system. Course scheduling is an integral part of institutional administration, yet there's little research into scheduling as a key factor in broader governance and strategic planning. It is natural to assume that a schedule is mostly tied to two of an institution's most expensive factors, facilities and faculty. However, we explore additional environmental factors like how the characteristics of a room affect its utilization, what overriding into a class is like for students, and how to better forecast demand for classes. The schedule of class times on the left shows the university's current distribution of class times in a regular semester and a regular week. Our project explores ways to expand those opportunities for classes to better serve the students of the university. The primary goal of academic scheduling is to develop class times that maximize a student's chance of having a workable schedule to graduate in 4 to 6 years. So our industry partner is the University of Arkansas Office of the Provost. The Provost is the Chief Academic Officer for the university who works with the Chancellor to set academic priorities and allocate funds to them. Under the leadership of the Provost, the Office of the Provost oversees all policy changes for the university, including academic and budgetary affairs. Both the academic and administrative units report to the Provost, including enrollment services, the Office of Institutional Research and Assessment, the colleges, and more. Within the course scheduling system, the Office of the Provost regulates course schedules by creating policies that define scheduling requirements. For example, Academic Policy 1200.3 sets the official meeting times and defines prime class time hours, which are from 9:30 a.m. to 2:30 p.m. We have been mainly working with the Office of Institutional Research and Assessment. They compile, analyze, and deliver information about the University of Arkansas community to internal and external constituents in order to foster more informed decision-making, data literacy, and institutional assessment. Luckily, today we have Gary here to talk a bit more about our partnership.
Hey, thank you, Alyssa. I'll just do a brief introduction as to the way that I introduced this problem to the team. They've all done a very fine job. And so, you know, the whole issue of class and course scheduling, we ran through it largely as an office during the early 2010s when there was a huge increase in enrollment. And so when that came about, we took a harder look at how classes were being scheduled, when to fit them in, how could we maximize our classrooms and our instructors and those types of things. So I sort of saw this when Dr. Cassidy came to me with a possible senior design project. I thought about this as sort of a process optimization problem for them. And so for the team, I gave them sort of a list of constraints. We have limited classroom spaces and types, limited instructors, and yet, this whole process has to be simple enough to be easily understood by the students and the staff that have to carry it out. A few of the factors for them to consider were just like things like distance between classes or between the instructor offices and classes, or the current prime time usages, the class sizes, the section counts. And then, there are some classes that are offered every semester and some that are offered, in that irregular. Maybe not, they may not be offered at 1 year, they may be offered later. And then I gave them some potential goals and sort of let them use their industrial engineering curriculum to decide, how to best fit these. And, the driving goal is just student success, for students to be able to get the classes that they need and that they want so that they can graduate. Also, to have satisfaction for the students, faculty, and the scheduling staff with the whole process. And some of that is that goal of being able to predict the number of sections and size that you need for each of those courses, for each of the semesters. And also because we are limited on facilities to optimize the space usage for those. So, I provided them data about our, historically on our classes, our classrooms, our enrollments, and that type of thing, and went back and forth with them on data points that they had and why some of these data points may be there, but they may not be completely accurate. And so I know they had to deal with some of those issues like any team would when they're working on a problem like this. So I'll let them go ahead and present their solutions. Thank you.
Thank you. So in our exploration, we found that course scheduling is a rather decentralized system, with the key contributors being the registrar, the colleges, and their subsequent departments. These parties, with the guidance of the Office of the Provost, collaborate on optimizing meeting times and making the schedule of classes. Michael is now going to explain a bit more about their roles and responsibilities.
Thank you, Alyssa. So as Alyssa mentioned, there are three main parties within the scheduling process. So the departments, the colleges, and the Office of the Registrar. So what I'll do is I'll go through this one-line chart of each of the steps that these groups take to make sure that the course and classroom scheduling process is executed. So the first step here is that the departments receive the previous schedule from the Office of the Registrar. So if they were planning to do fall 2020, they would receive a copy of the fall 2019 schedule to begin planning from. Next, what the departments do is they adjust their course offerings. So every year, departments all around the university might decide to change their curriculum, so remove classes or add classes, or there might be a new professor who wants to teach a certain class. These kind of changes are made during this step. Next, the departments assign the course details. So this is an important step where class times are decided, class meeting patterns. So is this a Tuesday, Thursday class, or Monday, Wednesday, Friday class? And also, how many students do we expect to be enrolled in this course? And how many sections do we want to create? So these types of details are created in this process. But this also requires a lot of collaboration between other departments and colleges, because if the departments want to make a change, then that will also affect other departments and colleges. So if you change the class time of a certain class, well, if there's already another class in that room during that time, then you have to come to them and say, hey, we want to be in this classroom now. And they can either decide that they want to accept that or not. And so there's some give and take during this process, and that does increase the time, and it can cascade into multiple decisions having to be made for different parties. And next, the colleges compile and validate the department's course offerings. So this is the step which makes sure that all of the provost policies are being followed, with the most notable being that 65% of the department's classes are scheduled between 9:30 a.m. and 2:30 p.m. during prime time. That certain courses are matched, so one-a-day-week courses are matched with another. And rules such as these have to be followed to make sure that the course is valid. Next, the colleges then enter the data into the course leaf classroom scheduler, which essentially compiles the information and gives it to the Office of the Registrar, who can then assign the meeting time and location to the course in 25 Live. And so the Office of the Registrar has that final decision about where the classrooms are being scheduled and when. And after this is done, they publish the course catalog in UA Connect. And at this point, students can now look at the courses and see them inside of UA Connect. But also during this time, there may be some extra conflicts that occur where the departments want to schedule a scheduling adjustment. And so those adjustments are managed by the colleges and then potentially approved by the Office of the Registrar. And that also is reflected in UA Connect. And then finally, the semester starts with the schedule where the students begin their classes. And also during this step and the last step, students can submit an override request to change a course that they want to be in, or enter a course which they weren't previously allowed to be in. And so for this last year, our team focused on three main areas within this process. First, on the top, you can see in assigning course details, we wanted to focus on how do we forecast demand for courses so that departments can know the correct number of sections or predict the number of sections enrollment that they'll need inside of their classes. Secondly, when assigning the time and location of the course in 25 Live, we thought that looking at general access classrooms and making sure that we're splitting the workload evenly among all of our buildings would allow us to have more opportunities for students to be able to get the classes they need because they have more times available to them, but also to manage our facilities correctly so that we can be prepared for further growth in the future. And then lastly, when the special starts with the schedule, the override process, specifically the override process for the industrial engineering department, how can we make it more efficient and more accessible and available to the students to get the overrides that they need. Next, I'll pass it over to Jacob, who will begin talking about some of the issues that we found with classroom utilization.
So when we began this project, we thought there could be some areas where the university could improve its policies and practices regarding classroom utilization. We found that there are not many measures of system performance besides 4- and 6-year graduation rates, and those are affected by a lot of different factors outside of course and classroom scheduling. So we believe that there are some opportunities to improve the methods that are currently in place when it comes to classroom utilization. Like an annual review of classroom utilization on campus could reveal areas where the university could improve. Also, not all classes are compliant with the university's official class time policy, and that makes us believe it makes it a little more difficult to create a cohesive schedule. And we found that there are 6 different environmental factors that could be contributing to lower classroom utilizations, such as room capacity, room location, prime time utilization, day of the week and time of day utilization, and the technology, and those all differ for each classroom on campus. And so overall, the classroom scheduling process is a really large and decentralized system with many different players involved that have control of a lot of different rooms on campus. So moving forward, I'll go through some of the performance measures that our team defined in order to evaluate course and classroom scheduling processes. So like I mentioned before, 4- and 6-year graduation rates seemed like performance measures that were being used to evaluate the process. So our team defined 4 different measures that we believe are critical in creating a successful schedule. Classroom utilization is defined as the percentage of rooms that are in use during standard class times. And this is found by taking the number of meeting hours in the reporting week in a room and dividing it by the number of possible hours in the room during the same time period. We also define a prime time utilization as an important measure, and that gives us the percentage of rooms used during the prime time class times, which are 9:30 a.m. to 2:30 p.m. And to find the enrollment ratio, we took the actual enrollment per section over the enrollment capacity. During our interview with the registrar, Dave Dawson, he made it really clear to us that he was particularly concerned with the enrollment ratio, and this was due to his concerns with the evaluating class demand on a semester-to-semester basis. And finally, we defined the percent enrolled as the actual enrollment per course over the university enrollment. And next, I'll hand it off to Olivia to go through some of the analysis we did regarding classroom utilization.
We will begin by looking at the current performance of classroom scheduling process at the university. When looking at the classroom utilization for the university, there are 2 classroom groups: general access classrooms depicted as GA on the graph, and special purpose classrooms depicted as SP. The general access classrooms are controlled centrally by the registrar's office, while the special purpose rooms are controlled by individual colleges. We focus on the general access space features for our analysis because the colleges are not required to release special purpose rooms for general university scheduling. As you can tell in the graph, the special purpose rooms have a much lower classroom utilization than the general access, which brings down the overall classroom utilization for the university. In the future, we hope further policies are put in place to increase special purpose utilization. When looking at the data from 2013 to 2019, we are above the national average of 49% classroom utilization for the general access classrooms. We were also able to determine that the prime time classroom utilization hovers around 65% on average, which corresponds to the Office of the Provost prime time policy that requires each department schedule no more than 65% of their classes during prime time. After assessing the current classroom utilization at the university, our next step is to determine which factors affect the utilization for different classrooms. Next, I'll discuss the university's current performance in predicting course demand. Enrollment ratio is a nationwide benchmark used to determine the accuracy of predicted course demand. As Jacob mentioned, the enrollment ratio is defined as the actual enrollment in a course over the course capacity. The graph shows the performance benchmarks identified by Ad Astra's analysis of over 100 universities nationwide compared to the university's metrics shown in green. The University of Arkansas's average enrollment ratio is significantly higher than the average enrollment ratio for the nation and 7% higher than the ideal enrollment ratio of 85%. The enrollment ratio can then be broken down further as a balanced course schedule is defined in the ideal range of 70 to 95%, with overloaded courses having an enrollment ratio above 95% and underutilized courses having an enrollment ratio below 70%. Although there is no ideal percent of courses for overloaded, balanced, and underutilized, we can see that the university has significantly higher percent of overloaded courses than the national standard, higher than even the maximum amount. One of the reasons for this is because the University of Arkansas adds sections as courses start to get full, resulting in an actual enrollment very close to the course capacity. Our goal for a more accurate forecast is to lower the average enrollment ratio to the recommended 85% and reduce the amount of overutilized classes. Finally, we'll look at the current administrative change of registration processes performance. For this process, also known as the override process, we focused on the industrial engineering department as shown in the swim lane below. The process starts with the students filling out an online PDF form that is then sent to the instructor for approval. Once the instructor approves, it's reviewed by Carrie Pennington, the program coordinator for the College of Engineering. And after this, the department head must approve the form before it's finally processed and sent to the dean's office. Within this process, the biggest area of concern is that 50% of the forms reviewed by Pennington are filled out incorrectly or are missing information and have to be returned to the student to resubmit. This essentially restarts the process and creates wasted time and effort for both the students and faculty. In the past few slides, I've discussed the current performance of the University of Arkansas's course and classroom scheduling. And next, Alyssa will begin expounding on the analysis we conducted to determine improvements in these metrics.
So probably the first feature that for our rooms we tested for correlation with utilization was the room's capacity or number of seats in the room. The figure on the left shows the current distribution of class sizes for general access classrooms at the university. Most importantly to note is that there are 7 extra large classrooms that hold over 200 people and 84 classrooms that hold 20 to 40 people, which accounts for some of the variation. We found that with these rooms, there's a slight positive correlation between the room's capacity and utilization, with its relationship appearing vaguely logarithmic. This indicates that there is slightly more demand for larger classrooms. However, facilities are costly. Instead of building new classrooms or buildings or breaking down walls, we recommend that the university use its smaller classrooms more effectively. This might mean having smaller classes or adding more sections to a class. Now, that is a greater teaching burden on the faculty. However, it would benefit students even more to have a smaller, more intimate learning environment. The next thing we tested for correlation was the categorical features of a room. We pulled around a list of over 20 features for classrooms, which include information like if it has a whiteboard or an HDMI cable or not. We found that with most of these features that they did not significantly affect a room's utilization, except for the furniture types, like having fixed tables with movable chairs and movable tables and chairs. But even more significantly was the technology type being either standard or standard light. We found that the standard technology type rooms had a higher quality and more expensive technology within them. These classrooms are mostly known for their central control panel that controls the computer and the projector screen and the height of the desk all in one. And the technology light is the less expensive, lower quality option without that central control panel. Using a 2-sample t-test, we found that the standard technology type rooms were significantly utilized more than standard light. This leads us to our recommendation of continuing to improve classroom technologies to keep up with the increased enrollment of the university, but also increase interest in the less utilized classrooms. That mostly summarizes how the features of a room correlate with its utilization. Next, Jacob will talk about more on our findings with classrooms and when they are scheduled.
So using correlation analysis, we found that there is a correlation between class utilization and the time of day And here we're just displaying it in cell format to really highlight the difference in what times are utilized and what times are not. So using data from 2019, the chart on the left shows that most classes occur between 9 a.m. and 3 p.m. And this is because all departments must schedule no more than 65% of classes during those prime time hours between 9:30 a.m. and 2:30 p.m. And the chart on the right shows that most classrooms are in use at 9, 10, and 11 a.m. and then again around 2 p.m. And this can most likely be attributed to professors having lunch breaks around noon and not wanting to teach as much during that time as the other prime time hours. So around 55% of classes during the 9 a.m. hour are scheduled before 9:30, and this means they are not considered prime time. This shows that departments may be attempting to front load their classes so that they can schedule other classes during prime time, which may also explain the lower usage rates between 12 p.m. and 1 p.m. Also, we found that Tuesdays and Thursdays are scheduled for the most time, while Monday, Wednesday, and especially Fridays aren't utilized as much. And this means that the university may be able to more evenly spread classes throughout the week by having more Monday, Wednesday, Friday classes. And that'll let the university add more capacity for more classes to be scheduled. Next, I'll go through what we found when looking through classroom and building utilization data. So we found that there was a correlation between building and classroom utilization in the day of the week. The chart on the left shows the 5 highest average utilizations by classroom, followed by the 5 lowest. For example, room 0408 in Champions Hall is used only 1 day a week, and that's on Wednesdays. And it's used only 11.4% of the time on Wednesday. This really highlights the difference in room utilization and that there are currently spaces on campus that may not be being utilized correctly. And the graph on the right also proves this. We used a formula from X25 that took the meeting hours that occurred in the general access classrooms in buildings from 7 a.m. to 5:30 p.m. and added in the 15 minutes required for passing time in between each classes. Next, we divided that by 9.5 hours to find the building utilization. And we found that Discovery Hall and Poultry Science were being underutilized. Discovery Hall under 45% and Poultry Science under 47%. And we would recommend that the university try and spread the distribution of classes a little more evenly throughout the week and throughout the buildings on campus. And next, Alyssa will go through what we found when evaluating the number of class time violations per building.
So we considered a violation if a class was not scheduled in an official class time. This means if they didn't follow the correct day meeting pattern or started early or went beyond the official class time. For example, a regular official class time would be Monday, Wednesday, Friday, 9:40 a.m. to 10:30 a.m. To only have that class on Wednesday or Friday would be a violation. To start at 9:35 would be a violation, or to go beyond to 2 p.m. would be a violation. The figure on the left shows the results of a Pearson correlation test between the number of aggregated class time violations for fall 2017, 2018, and 2019 with building utilization. We found that there is not a significant correlation between them, but there is a positive trend indicating that if a building has more class violations in a classroom, it might actually be utilized more, which went against our original hypothesis. However, as we looked into the buildings in which these violations were scheduled, we found that the building with the most violations in this period was the science building, which is often known for having lab classes that go beyond the hours of a regular class meeting time, which could account for the most violations in that period. Next, we looked into the distance of a building, the distance between a building and its closest neighbor and the building in the center of campus with utilization. We did this by finding the longitude and latitude of each building on campus and then measuring the distance between it and its closest neighbor and the average center of campus. We found that with we did this for fall 2017, 2018, and 2019. Displayed on the screen is 2019, but we found there was very little correlation with the distance in utilization. For example, between a building and its closest neighbor, the R squared was 0.09, leading it to be not significant at all. And then the distance between the mean center and the building, we had a bit of a better R squared with it being 0.23. However, that did not have 0 in the confidence interval, making it a not significant test. And this is reflected in the other years too, for 2017 and 2018, with their R-squares being even less. Next, Olivia is going to go more into the forecasting demand portion of our project.
In our analysis of predicting course demand, we focused on state minimum core courses, which are courses required for all students at the university to graduate. This list includes math, English, science, history, social science, and fine arts classes. An average of 31.9% of courses offered at the university are state minimum core courses, and they're a good representation for the university's overall health in predicting enrollment demand. Shown on the screen are models for English 1013 Comp 1. We initially created 4 models to forecast demand: the Holtz-Winters percent enrolled forecast, the ARIMA percent enrolled forecast, the Holtz-Winters census forecast, and the ARIMA census forecast. The percent enrolled models use the percent of students enrolled in the course divided by the university's enrollment for N-1 terms. For example, when looking at the percent enrolled forecast, the y-axis shows the outcome of 2 to 6% of university students enrolled in Comp 1 from 2016 to 2020, while the census forecast shows the outcome of 500 to 2,000 students enrolled in Comp 1 from 2016 to 2020. We calculated the mean absolute percent error for each of the models for each course to determine which model to use in our forecasting tool. To compare the mean absolute percent errors of the models, we conducted 6 two-sample t-tests and found no significant difference in the average MAPE. Below, 2 of the tests are shown with high p-values. One of the reasons there's no significant difference in the average MAPE of percent enrolled in census forecast is that the university has had consistent enrollment from 2015 to 2020, the years the data is based on. However, we chose to use the percent enrolled forecast because it allows for greater accuracy in times of major growth or decline in the university. We also decided to use the ARIMA model over the Holtz-Winters model because it had a lower average MAPE. Therefore, we used the ARIMA percent enrolled model to forecast all state minimum core courses. After forecasting each state minimum core course using the percent enrolled ARIMA model, we determined that the average MAPE was 14% and the average enrollment was 85%. By conducting a two-sample t-test, we found that the enrollment ratio for the forecasted courses is significantly lower than the actual enrollment ratio for these courses. The difference can be seen in the graph on the right. Using the ARIMA forecast and adding an allowance of 1.178, we were able to lower the average enrollment ratio from 91% to the nationally recommended enrollment ratio of 85%. Next, Michael will discuss the tools we created for the university and recommendations we made.
Yeah, so the tool that Olivia used to create the forecast is here. So this is an Excel VBA, and what the user can do is on the left is go to the historical data table. So for instance, this is Chem 1103, which is University Chem 1. So whoever is using this, which would be probably a course scheduler for a department or a department scheduler, would come in here and click get course data and receive the percentage of students enrolled for every semester, historical semester. So this is also can be updated. Gary has a query that you can run that will automatically pull the new data for each semester, and this can be updated there. But for here, we have all the way to spring 2020. And once that data is pulled, on the right, you can go to the forecasted data table. And when the forecast button is clicked, it will find a number and have this connected to the ARIMA model in R. So that predicted number of 1,028 for the fall of 2020 is based on the percentage forecast, which is multiplied by that university enrollment of 22,025 students. And that's where the 1,028 number comes from. And then this is adjusted to get an 85% enrollment ratio, which is seen highlighted in yellow, which is the 1,209 expected enrollment. For classroom utilization, we also created an Excel VBA visualization tool to compare the utilizations of buildings and classrooms. And what this can be used for is when you want to compare or understand maybe the trends that are in between different classrooms, or if you look at a certain building, if you take Bell, for instance, you can compare all 5 of the classrooms inside there that are general access and compare their performance. And so in this tool, you can change the time period start and time period end that you're looking at. So intuitively, if we wanted to change that to 9:30 a.m. as the start and then 2:30 p.m., then you can get the prime time utilization for these buildings or classrooms. But currently it's set as kind of a normal school day, which is from 7:30 a.m. to 5 p.m. And then you can select up to 5 of these classrooms or buildings. And then when you click generate report button, it generates the graph on the right, which shows it by day of the week and the percentage of each classroom at that time. And finally, for the override process, we are recommending that the industrial engineering department switch to more specific instructions. So on the left, you can see the current instructions that students are given to fill out the override form. As you can see, they're a little bit lacking compared to the biological sciences instructions on the right. So giving more instructions and clarification about how to do it will, we hope that will decrease the rate of rejection so that students get the overrides they want. And they don't end up missing out on those because they didn't notice that their override was rejected. But as the university as a whole goes, we also recommend starting to look at a centralized override process. So we did some stakeholder interviews with the College of Business, and they have an online override process that actually keeps track of data for which courses and the reasons for which an override is being requested. And we think this is extremely important because the number of overrides can also indicate the student satisfaction with the courses. So if there are a large number of overrides for a certain course, you might understand that maybe this course needs to be changed in the curriculum to be earlier because there's so many students that are just requesting to get in it anyways. And although there might be some challenges with changing to an online format that collects data for the entire university, such as in the engineering and for engineering departments, to be ABET certified, the department heads have to manually approve any overrides that occur. Even though there are challenges like these, we do still think that being able to track the data and understand the satisfaction of students to the schedule is very important. So kind of summarize what we've done with this project. Our problem was that we wanted to address lower than ideal classroom utilization to incorporate growth for the university, high enrollment ratios, and student override errors. And we did this by conducting stakeholder interviews with folks all the way from the office of the registrar and the registrar down to classroom schedulers for the departments, course schedulers for the departments. And then what we did with this data and information that we collected is we approached it by conducting correlation analysis on features of rooms, which affect utilization. We created a room of forecast and continued interviewing college schedulers to understand better the override process. And then finally, we created Excel VBA tools to visualize classroom utilization and forecast enrollment for the future. That is our presentation. We're open for questions, especially Dr. Robinson. If you'd like to ask a few questions first, we'd love to hear from you.
Sure, that was an excellent presentation, and I learned a lot. I guess one question I have, did you look at, I know Gary mentioned student success. Did you ever look at any data that assessed how students performed at different times of the day relative to classroom utilization?
Well, that is a great question. So we actually did look at that slightly at the beginning of the fall semester, and that was one of the things that we wanted to look into. We didn't quite have enough time, but the data, it does exist there. So I think what was if anyone remembers the rate, it's the DFW rate. So we do have the DFW rate on that, and if we had a little bit more time, we definitely would have gone into that further. But we did find some research which indicated that there were some certain times a day for particular universities that worked better, but we'd have to look at the University of Arkansas to see what trends may exist there.
Sure, no, that's quite understandable. I noticed in one slide you had the Tuesday, Thursday classes were very heavily utilizing those kind of prime time, and Monday, Wednesday, Friday. I wonder how much of that is driven by the faculty requesting those times, and as opposed to, you know, these selections just being made organically.
Yes, yeah, Alyssa, go ahead. Go ahead.
It's kind of along with your last question of, it's not so much as students prefer that time, but it's the time that they accept when they register. But most of our hypothesis on the Tuesday, Thursday popularity is because they are longer class time blocks, which provide a longer lecture time for instructors to teach within, but also it's not as frequent of a meeting time, which often leads to people being able to make it.
How does Monday, Wednesday compare? Because I mean, it's a similar time. You can do a similar, you know, time slotting with a Monday, Wednesday, but I don't see many of those. At least I haven't historically seen many of those.
Well,
go ahead.
I mean, as for their individual performance, we don't necessarily have data on that, but we know that Friday is not necessarily as popular as a normal Monday, Wednesday, Friday would indicate. So,
right. There's probably some of that happening with those Monday, Wednesday courses, and that might be another reason why Friday is less populated. So, but no, this is excellent. I mean, I you know, I'd have to take a deeper dive. I'd love to get a copy of your charts and just kind of be able to look at them in my time when I can think about how, you know, the implications in your recommendations. So thank you for letting me observe. I'm sure there'll be more questions that I'll develop over time as I think through it.
Well, certainly we can send you a copy of our report, which has everything in more detail, and there are a few more charts and explanations kind of behind things.
That'd be great. Thank you so much.
Yeah, absolutely. Thank you, Dr. Robinson.
Uh-huh.